The pH of a weak base. In this case, we're going to dissolve sodium fluoride in solution, 0.4 moles per liter of it. The deal here is that fluoride, F-, is actually a weak base. When you put it in water, some of the fluoride will steal protons from water, create its conjugate acid, and if you steal an H from water, what you end up with is hydroxide ions, OH- ions, which makes the solution basic. Now the deal here is that you've started with the base and ended with hydroxide. This is going to be our Kb expression because you start with the base. And the equilibrium expression for that is HF times OH- all over F-. And that's because you don't include liquid water, and to create your equilibrium expression, you do products over reactants. Pretty basic so far. Basic, get it? Okay, now I want to do an ice table. F-, making HF and OH-. Remember, I'm not including water because water is a liquid and we don't include it in equilibrium expressions. The initial concentrations. Well, fluoride is 0.4, and we're not starting with either of these. See, we only start with some fluoride ions. FYI, the sodium here does not play a role in pH. The change, I'm going to lose some fluoride, gain some hydrogen fluoride and hydroxide, so my equilibrium concentrations are 0.4 minus X, X, and X. Oh, I feel a substitution coming on. Kb, oh, I don't know Kb. I guess I'm going to have to figure it out on my own. Kb is 10 to the negative 14, that's Kw, divided by the Ka. I can't believe I almost overlooked that, eh? You've got to be able to use this equation, this 10 to the negative 14 divided by Ka, in order to get Kb, and vice versa. 1 times 10 to the power of negative 14 divided by 6.3 times 10 to the power of negative 4 gives me 1.59 times 10 to the power of negative 11. I can use that to plug in to my equilibrium expression. Kb, 1.59 times 10 to the negative 11 equals HF, that's X, OH-, that's also X, and F- is 0.4 minus X. Now I'm going to assume that X is small relative to 0.4, which is almost definitely a good idea because K is so small. And now I just have to solve for X. Well, how do I undo division by 0.4? I undo that with multiplication. 1.59 times 10 to the negative 11. And on top here, I'm left with x squared. On my calculator, I multiply that by 0.4, just like we said. That gives 6.35 times 10 to the negative 12. And to solve for x, I take the square root of both sides. I'm left with x is 2.52 times 10 to the power of negative 36. There we go. That is my x, which was my concentration of OH-. Now the original question asked for pH of the solution. How are we going to do that? Here's how I recommend doing it. My POH is the negative log of my my OH- concentration. So I'm just going to sit here, take the negative log of this, and I get 5.60. Then, to bring her home, I can do 14 minus the POH, and that will give me the pH of the solution. When I do that on my calculator, I end up with 8.4. That's a basic pH, which makes sense because we put a weak base into the solution. Alright guys, to find the pH of a weak base, set up your equilibrium, create your Kb, use an ice table. You may have to calculate Kb from a given Ka if it's for the conjugate acid, and then solve it like you would any other equilibrium expression. When you end up with OH minus, get the POH by taking the negative log, then subtract it from 14. Several extra steps to do a weak base compared to weak acid, but that's chemistry. What you gonna do? Best of luck.